Let's do lesson 22 practice problems. All right, question 1. To qualify for a loan from a bank, the total in someone's checking account and savings account together must be more than $500. Which of these inequalities best represents this situation? So on this one, the key here it has to be $500 or more. So that means it could be 500 or it could be more than that. And so that is automatically going to eliminate the ones that are just less than and greater than, because it can be exactly $500. And so to figure that out, or the choice is going to be the last one, because the X and the Y represent the checkings and the savings. And when I add those together, they have to be greater than or equal to 500. Part B says complete the graph so that it represents solutions to an inequality representing this situation. Be clear about whether you want to use a solid or a dashed line. So if I'm going to be graphing that previous inequality, x plus y is greater than or equal to 500, because it is a greater than or equal to, I'm going to be using a solid line because it can equal exactly 500. And then I need to figure out which side am I going to shade on. So I'm just going to pick a point. Our nice easy one is just 0, 0 is my xy. If I was to substitute that in there, I get 0 plus 0 is greater than or equal to 500. That is not true. 0 is not greater than or equal to 500. So the origin is not part of my solution set, which means everything on the other side of that boundary line is. Question 2. The soccer team is selling bags of popcorn for $3 each and cups of lemonade for $2 each. To make a profit, they must collect a total of more than $120. Write an inequality to represent the number of bags of popcorn sold and the number of cups of lemonade sold. So it's $3 for each, is selling bags at $3 for each bag of popcorn. So that would be 3p plus 2c, because you're making $2 for each cup of lemonade. And then we need to make more than, not more than or equal to, just more than $120. So that would be my inequality. Graph the solution set to the inequality on the coordinate plane. So on this one, I need to graph that inequality. I would probably, on this one, I'm probably going to do the intercepts. I think that's going to be the easiest, although there's different ways that you could come up with the equations. So if p equals 0, what would c have to equal? It would have to equal 60, because 0 plus 2 times 60 is equal to 120. And then if I make the c is equal to 0, then p would have to equal 40. Okay, so here, 0, 60 is going to be right here, and 40, 0 is going to be right here. And, if this was just a line, I would just go ahead and connect these, okay? And that would be my line. But because it's an inequality, you have to think about, is it going to be a solid line or is it going to be a dashed line? And because it's a greater than, that tells me that it's going to be a dashed line. So instead of using that solid line, I'm going to go back and I'm just going to make that a dashed. And then we need to figure out which side are we going to shade. So again, if I take my favorite test point, 0, 0, for PC, and see if I plug that in to my equation, I'm going to end up getting 0 plus 0 is greater than 120. Definitely not true. So that means the origin is not part of my solution set. So I'm going to shade everything to on the other side of that boundary line. C, explain how we could check if the boundary is included or excluded from the solution set. Well, the way that we could check it is we could pick I'll go ahead and write it. We could pick a point on the boundary and see if it works. Okay, so if I just take, I've already got a couple here. So let's say I do 40, 0, okay, which is, right down here on my horizontal axis. If I plug 40 and 0 in, I get 3 times 40 plus 2 times 0 is greater than 120. And that is, the left side ends up being 120 because that just goes away and you're left with 3 times 40. And 120 is not greater than 120. Okay, so That's how we can check to see if the boundary is included or excluded, by plugging a point that's on there and seeing if it works. Question 3. Tickets to the aquarium are $11 for adults and $6 for children. An after-school program has a budget of $200 for a trip aquarium. If the boundary line in each graph represents the situation, 11x plus 6y equals 200, which graph represents the cost of the constraints of this situation? So here, the budget is $200. So that means I need to stay under $200, or it could be exactly $200. So here you notice the equation just tells me where that boundary line is. But the actual inequality would be 11x plus 6y has to be less than or equal to $200. That's my constraint. It's what it needs to stay under. So which one of these graphs is it going to be? Because it's a less than or equal to, that means that the boundary line, the points on it work. So automatically I can eliminate A and I can eliminate D, because those use dashed lines, okay? And on this one, because it's a less than or equal to, it wouldn't be a dashed line. So then the question just becomes, am I going to be shading above or below that line? Well, if this is a constraint, you can use just a little bit of logic and reasoning here and realize that it should be, in this case, the graph where the line is shaded below. Because, if you choose the one that's shaded above, then that's just telling you, like, you could pick any combination. For example, let's say I went out here to 2020. Okay, and if I picked 2020 as a test point and I was to plug it into that equation, that inequality, 11 times 20 plus 6 times 20 is definitely not going to be less than or equal to 200. That doesn't work. So I shouldn't be shading above the line. I should be shading below the line. So in this one, it's going to be choice C. Question 4. Tyler filled a small jar with quarters and dimes and donated it to his school's charity club. The club member received the jar, asked, "Do you happen to know how much is in the jar?" Tyler said, "I know it is at least $8.50, but I don't know the exact amount." So just as a little reminder here, for those of us that aren't Americans, quarters are 25 cents, which can be represented by 0.25, and dimes are 10 cents, which can be represented by 0.10. So to write my inequality in part A, I'm going to take the number of dimes times 0.10. I'm going to take the number of quarters and multiply that by 0.25. And you're told that you have at least $8.50. So that means it can be $8.50 or more. So the amount of money I have is going to be greater than or equal to $8.50. B, graph the solution set to that inequality and explain what a solution means in this situation. So we'll start with the graph. Again, I'm going to go ahead and start with, I'm going to do my intercepts again. You could put this into slope-intercept form if you wanted to, but I'm just going to go ahead and put the D and the Q. And if D is equal to 0, that's essentially going to cancel out that first term, because 0.1 times 0 is 0. So 0.25 times, let's see, Q is going to be, if I'm doing my mental math right here, I'm probably going to mess this up here. 0.45, 34. Hopefully I got that right. So that's going to be right here. Okay, 0.34. And then if I make my quarters equal to 0, then the dimes are going to be 85. That one's a little easier to do mentally. And so that's going to be right out here. And because it's a greater than or equal to, I'm just going to do a solid line on this one, because I can actually, those values that those coordinates that I just used actually work. And we know that I have at least $8.50. So everything that's greater than $8.50, so for my line, that's going to be everything up above here is going to be a solution to this inequality. Let me label this other one, 85, 0. And if you wanted to make sure, you could go ahead and pick a point and see if it actually works out here. Or actually, just if you pick 0, 0 and see, does that work? Well, if I put 0, 0 into this, I'm going to end up with 0 is greater than 850. Definitely not true. So that means that point's not in my solution set, so it needs to be everything else on the other side of the line. Okay, and so what does that mean in this situation? So this would be all of the combinations. I'll say all of the quarter, dime combos that are more than, actually, let me use the same language, that are at least $8.50. So if I picked like this one way out here, 90, 50. So that means if I had 90 dimes and 50 quarters, that's going to be more than $8.50. Part C says, suppose Tyler knew there are 25 dimes in the jar. Write an inequality that represents how many quarters are in the jar. Okay, so that means that I'm going to take this, let me just take this inequality that I've got right up here. I'm going to copy that, move it down here. But now instead of 0.01D, I can substitute 25 in for D. So I can substitute that right in here. And when I do that, 0.1 times 25 is going to give me 2.5. So I'm just going to erase this first one and replace it with 2.5. And now I just need to write an inequality of how many quarters there are in there. I could leave it at that, or you know what I'm going to do? I'm going to solve for Q. So I'm going to take away 2.5 from both sides. So 0.25Q is greater than or equal to 6. Divide both sides by 0.25. And that gives me the number of quarters has to be greater than or equal to 24. Okay, so that's if we know how many dimes are actually in there. All right, getting into some of the review problems. Question 5. Andre is solving the inequality listed there. He first solves a related equation, 14x plus 3 equals 8x plus 3, and it goes through and he solves that out. This seems strange to Andre. He thinks he made a mistake. What was his mistake? So on this one, his mistake happened going from step 2 to step 3. And what it looks like Andre did is he tried to divide both sides by x. And as we learned earlier in this unit, you can't divide both sides by x, because when you do that, you possibly eliminate a solution. So his mistake was dividing by x. If we were actually going to solve this, it doesn't ask you to here, but I'll go ahead and show you anyway. It's okay, the first one you'd take 3 away from both sides. On this one, you want to get the x's on the same side. So I would probably take 8x from both sides. That would leave me with 6x is equal to 0. Divide both sides by 6. And what do you know? You get x is equal to 0. So that's what the solution should have been. But the mistake was that he was dividing by x, which you can't do. Question 6. Kieran says, I bought 2.5 pounds of red and yellow lentils. Both were $1.80 per pound. I spent a total of $4.05. Okay, so write a system of equations to describe the relationship between the quantities in Kieran's statement. Be sure to specify what each variable represents. So I'm going to use R for red and yellow for and so let's go ahead and write that down. R would be the number of red lentils, and yellow is going to be the number of yellow lentils. I'm just going to be a little bit lazy here and just write yellow. Okay, and so the first part is, well, I should say, let me be a little bit more. Number of, I always want my students to be exact. So the number of pounds, because this is what this question's, the number of pounds of red lentils. Okay, so the first thing is, you got 2.5 pounds total. So that would be r plus y is equal to 2.5. And then the second part brings in the money. Both were $1.80 per pound. So $1.80 times the pounds of red plus $1.80 times the pounds of y is going to be equal to 4.05. Okay? Or if you wanted to be a really clever mathematician, this would be your system. That second equation could have also been written as 1.80 times r plus y. Okay? Equals 4.05. Either one of those would have been acceptable. Elena says, that can't be right. Explain how Elena can tell that something is wrong with Kieran's statement. Let's see here. So, how can she tell something is wrong? So, the way that she can tell something is wrong is if she went through and tried to solve this. On this one, I realize I put a red there. That should be a yellow. There's going to be a problem if you look, especially if you look at like the first equation and that second form of the other equation. Because just imagine that that second equation, if I was going to, let me rewrite it, 1.80 r plus y is equal to 4.05. If I was going to, let's say, try to like simplify this a little bit and divide both sides by 1.80. Okay. Those would cancel out, and I'd be left with r plus y is equal to 4.05 divided by 1.8 is, well, I don't have a calculator handy here, but it's not going to be equal to 2.5. So it's going to be equal to something else. So you have this first equation where it says r plus y is equal to 2.5. That second equation is going to be r plus y equals something other than 2.5. Okay? And those two statements like can't both be true. Like r plus y can't equal 2.5 and at the same time not equal 2.5. So that's how we know that something is wrong with Kieran's original statement. And see, it says, Kieran says, oops, I meant to say I bought 2.25 pounds of lentils. Revise your system of equations to represent this. So here, 2.25 pounds is what we should have written in that first equation. So this would become r plus y is equal to 2.25. And then the second one's going to stay the same. So the second one I could leave as, I'll leave it in the form 1.80 times r plus y is equal to 4.05. And D says, is it possible to tell for sure how many pounds of each kind of lentil Kieran might have bought? Explain your reasoning. Yes, it is, because we've got two equations and two unknowns. So I'm going to say yes, because I have two equations and two unknowns. And as long as you have, you can solve, like if you've got two variables, you can go ahead and you can figure out what they both are if you have two distinct equations, two different equations. So that would be the case in this one. And it doesn't actually ask you to solve it, so that's all we have to write there. Question 7, here is an inequality. Select all the values of x that are solutions to the inequality. So this one just becomes a matter of kind of substitution. So I'm going to take negative 0.2 and plug it into here. So that's negative 7 minus 3 times negative 0.2 plus 2 is less than negative 8 times negative 0.2 plus 1. I'm only going to work out one of these just so you can see how it's done. So this is going to become negative 7 minus negative 0.6 plus 2 is less than negative 8 times 0.8. And really, you don't want to, I mean, you could distribute that 8 in there, but you don't want to do that. Like, it just follow your order of operations. It's easier. You're going to be less likely to make a mistake. So I keep going. -7 minus, this works out to be 1.4 is less than -6.4. This is going to be -8.4 is less than -6.4. Is that a true statement? Yes, it is. So that means that A is going to be one of the values that is true for this one. To check to see what the other ones are, you can just look at an answer of the answer key, but I'm not going to go through and do B, C, D, E, and F. But for all of them, you're going to take those values, substitute it into the equation, and see if it works. 8, here's a graph of the equation 6x plus 2y equals -8. Are the points 1.5, -4, and 0, -4 solutions to the equation? Explain or show how you know. I would probably just plug them in and see if it works. So here's my x and my y. So let's check that first point. I would do 6 times 1.5 plus 2 times -4 and see, does that equal -8? I don't believe it is. This is going to become 9 minus 8, which is equal to 1, which is not equal to -8. So that point would be a big old no, negatory. And you can see, like, if I look on my graph, 1.5 -4 is going to be right here, which is not on that line. So you can either show it by, like, going through and substituting the point in, or you can just plug it in and or look at the equation. So like on that second one, 0, -4, that is on the line. So we could say yes. And if you don't want to go through and show the steps like I just did right there, you could just say it's on the line. That's how I know that it's a solution. All right, B, check if each of these points is a solution to the inequality. So -2, 2. So if you notice this one right here, 6x plus 2y is less than or equal to -8. That's the same as the equation right up here. So the boundary line is going to look the same. Okay, it's already there on the graph. So I'm just going to go and see, are these, see where these points are. So -2, 2 is right there on the line. So I know that that is going to be a solution. 4, -2. So I go over 4, down -2. That's right there. Now, it's not on the line, so we know it's not a solution to the equation, but it still might be a solution to the inequality, so we have to check. So I'm going to plug 4 in for x, -2 in for y. So that's going to become 6 times 4 plus 2 times -2. Is that less than or equal to -8? Let's see, 24 minus 4. That is not going to be less than -8 because that gives me 20. So that is a big ol' no. 0, 0. Now, I could plug 0, 0 in and see if that's going to work, but you can see 0, 0 right here. And if this is not a solution, if 4, -2 is not a solution, then 0, 0 is not going to be a solution either because it's on the same side of the boundary line. I mean, we'll go through and double check it real quick, but I get 6 times 0 plus 2 times 0, and that's going to end up being 0 is less than or equal to -8. Not true, so I know it's not a solution. Now, what about -4, -4? That's over here in the third quadrant. -4, -4. Now, that should be a solution because it's on the opposite side of the boundary line. So I could say, I already know that that's going to work, but let's just go through and show it algebraically. So I'm going to have 6 times -4 plus 2 times -4. And I want to see, is that less than -8 or equal to? Well, -24 minus 8 is -32, which is definitely less than -8. So that is a solution. So which side am I going to? Going down to part C, shade. I'm going to be shading the left side. And I know that I'm shading the left side because -4 was a solution, whereas these other two were not. Are the points on the line included in the solution region? Explain how you know. Well, they are going to be included, okay? The reason I know is that this is a less than or equal to problem, and that I also checked by looking at like -2, 2 is it's on the line, and it makes the inequality true. So I could say, how do you know? I could say it's because less than or equal to inequalities. Let's see, because less than or equal to inequalities, the points on the line, I would say make both sides equal. Thus, a true statement. Doesn't have to be worded exactly like that, but something it implies, like it's okay for both sides to be equal to each other when you are dealing with something that's less than or equal to or greater than or equal to.